kinetic energy. Kinetic energy is basically the amount of energy that something has when it's moving. So let's call it kinetic energy, Ke, energy of movement. So when something moves from point A to B, as it is moving, it has energy, which means it has to be moving to have energy. So it has to have a velocity in meters per second. So that's how many meters it will go in a second's time. Okay, so basically, as something stops there, its kinetic energy, as it slows down, its kinetic energy will go down as well. Okay, that's because it follows a simple pattern, and there's a formula that explains this. Okay, kinetic energy equals right, let's start again. Kinetic energy equals half mass times velocity. Velocity is meters per second, so how many meters it's traveling per second. So the reason this is important is because basically kinetic energy is obviously linked completely to that. Okay, so basically if that's 0, then it means that the answer will be 0, because anything times 0 will give you 0. Okay, so even if mass was massive, if it was a ton lorry or 1,000 kilos times 0, it would still be 0 kinetic energy. So you need there to be some movement for there to be any kinetic energy. Okay, so this also points out the fact that if the thing doesn't have any mass, so if mass equals 0, then it could be 0 kilos, because that's the units we use for mass, times 1,000 meters per second for velocity. So this is mass times velocity times half. If mass was 0 and that was 1,000, the answer would still be 0. So kinetic energy would still be 0. So the two things that kinetic energy kind of measure are the movement energy, which is made up of mass of the thing moving, object, and the velocity of the moving object, or speed. So if we think about that in a clever way, kind of an example that you can imagine, if you imagine a bike that's 5 kilos, plus the weight of the person on the bike, maybe 60 kilos, and we have to put the half in whenever we're doing a calculation with kinetic energy. Okay, so we've got the kilos here, so that's in the units of kilos. And that's the mass. And the bike's going at, let's say, 3 meters per second. Okay, so what do we expect to get? Well, we expect to get something like, let's just say 90 something kilos. Okay, because 65 times 3 would be 195 divided by half. Well, we know that 90 times 2 is 180, so let's just say 195 is similar to 180 and divide that by half, 90 kilos. It's very approximate. This is just for an illustration. If you're doing it in an exam, you have to do it a bit more carefully than that. Okay, so if you're doing it in an exam, it would be something more like 97 kilos. Okay. Alright, so, but let's look at the lorry then. Let's say that's the bike. No, that's not in kilos. So that's actually the kinetic energy we're working out, which is in joules. So, okay, so that's because we've done the amount of kilos, the mass, times the speed, which has given us the answer in joules. Let's just say it's 97. Let's go with the more accurate one. Okay, then let's call that the kinetic energy of a bike. Okay, 97 joules. Now let's compare that to a truck going at the same speed. Half times, let's just call it 1,000 kilos, just so it's easier to do the calculation. Meters per second. Okay. So that'll be about 1,500 joules. So that is a huge amount compared to that. And I mean, they're both going at the same speed, but it just shows you that kinetic energy can be really influenced by either mass or speed. And just remember, the units should always be mass in kilos, speed in meters per second, and energy in joules. So that means if in the exam you are given mass in grams, to get that to kilos you divide by 1,000. Because a kilo is telling you that there are 1,000 things. So 1 kilo equals 1,000 grams. Alright, but if we wanted to go back from there to there, we'd have to times by 1,000. Because 1 kilo is equal to 1,000 of them, and a gram is equal to 0.001 of a kilo. Okay, so that's the mass units that you have to worry about. Energy will basically be the same. It might be given in kilojoules. You've got to make sure that if it's in kilojoules, you divide by 1,000 again to get it to joules. So anything with kilo in front of it, actually that's the wrong way around, you times it by 1,000 because you're going from the 0.001 to the 1. Okay, so for example 1 joule equals 0.001 kilojoules, and if we times that by 1,000 we can see that that's true, because that times 1,000 would go 1, 2, 3 places to the right and give us 1 joule. Okay, so energy, it should be in joules, but sometimes it might be given in kilojoules. So joules is what it should be by standard units. Okay, and kilograms is what it should be in the mass, and meters per second is what it should be for our speed or velocity. So just remember, it's mass and its speed that matters. If either of them is 0, then you won't get an answer for kinetic energy other than 0. That is a very important thing to remember. So if you remember anything, remember that it is the energy of movement that defines kinetic energy, and something moving has to have a mass to exist, otherwise it doesn't exist. Everything in the earth has a mass. So in order to have a kinetic energy, you have to have a mass so that something exists, and it has to be moving so that it has energy of movement.